In this video, we are going to learn how to define the inverse secant, cosecant, and cotangent functions. We've only talked about sine, cosine, and tangent so far, so now we're looking at their reciprocal functions. Now, the way they're defined is a little bit different. You'll notice that secant is the reciprocal of cosine, so its output is still also 0 to pi, but its input can't be anything between -1 and 1. So we use this little absolute value of x is greater than or equal to 1 to make sure there's no numbers too small in magnitude that go inside of it. As you remember seeing in its graph how it turns away from the x-axis, it's missing all those values in the middle. This accounts for that. Now for cosecant, very similar to sine, it goes -pi/2 to pi/2 for its range. And again, same thing as secant inverse. Its input has to be somewhere it's not between -1 and 1. And lastly, we have cotangent inverse of x, which is the reciprocal of tangent, but you'll notice a distinct difference is the input is no longer -pi/2 to pi/2, but now it's 0 to pi. And its input can be any number you want it to pick, just like with tangent. Now let's look at a few examples. Over here we have cosecant inverse of 2, which can be written as cosecant theta is equal to 2, meaning what angle makes cosecant equal to 2, which a very popular strategy would be, instead of thinking of what does cosecant theta, what angle makes cosecant theta equal to 2, think of it more as the reciprocal of cosecant of theta, which would be sine of theta, and the reciprocal of 2, which is 1/2, is what angle makes sine 1/2. Now luckily you still have that same range to pick from, so along -pi/2 to pi/2, sine is 1/2 at pi/6. So this expression, cosecant inverse of 2, is equal to pi/6. So we can use its reciprocal function to make it a little bit easier to evaluate. But if you're very comfortable with cosecant, secant, and cotangent, you can easily just jump from here to the answer. You don't have to write this extra step. Next up, we have cosecant inverse of -1, which means that I'm looking for what angle makes cosecant equal to -1. Conversely, the reciprocal of -1 is -1. So what makes sine of theta equal to -1? Well, that happens at -pi/2. So cosecant inverse of -1 is equal to -pi/2. Continuing forward, we have secant inverse of 2 square roots of 3/3. So now I need to figure out what angle makes secant of theta equal to 2 square roots of 3/3, or cosecant, or makes cosine of theta equal to 3/2 square roots of 3, which I need to rationalize. So multiply the top and the bottom by the square root of 3, giving me 3 square roots of 3 over 2 times 3, which would be 6, which simplifies to just the square root of 3 over 2. So what angle makes cosine of theta equal to the square root of 3/2? Well, that would happen at pi/6. And again, I'm picking any angle from 0 to pi this time, and the angle I'm going to pick will be pi/6 to make that happen. That is a 6. I made a little mistake by drawing a 3 on accident. Next up, we have secant inverse of -2, which means what angle makes secant of theta equal to -2, or cosine of theta, its reciprocal, equal to -1/2, the reciprocal of -2. Well, that would happen either at 2 pi/3 or 4 pi/3, but since I'm bound to this range of 0 to pi, 2 pi/3 would be the angle I use. So it's this statement, secant inverse of -2 is equal to 2 pi/3. Now lastly, I want to talk about cotangent. Now this one can be the more complicated one, only because the range of cotangent, it does not equal the range of tangent, but I'll show you a very easy way to handle that situation. So right here I have cotangent inverse of square root of 3, which can also be written as cotangent of theta is equal to the square root of 3. And now what angle makes that happen? Or I can think of it as tangent of theta is equal to 1 over root 3, which when rationalize is square root of 3 over 3. Now this happens at pi over 6. Oh, sorry, yeah, pi over 6 for tangent, which means that its reciprocal cotangent of pi over 6 should be square root of 3. And pi over 6 is in the range of both functions, so it works out just fine. So the answer is pi over 6. Now when we get to the negatives, this is where something tricky comes up. So cotangent inverse of negative square root 3 over 3 can be rewritten as cotangent of theta is equal to the negative square root of 3 over 3. Or tangent of theta is equal to negative 3 over square root of 3, which again, when rationalized, gives me negative 3 square roots of 3 over 3. And then lastly, just negative square root of 3, which for tangent, tangent is equal to negative square root of 3 at negative pi over 3. But conversely, the angle 2 pi over 3 also makes tangent negative square root of 3 because its cycle is pi or a half rotation. So after a half rotation, we land on 2 pi over 3, which also makes cotangent negative square root of 3 over 3. So the answer becomes 2 pi over 3. So you have to keep that in mind. If you find yourself accidentally using a negative angle for cotangent, just go straight across the unit circle and you'll find the proper angle to use. And that is how you define the inverse secant, cosecant, and cotangent functions.